Okay, day 4, solve by factoring. So what we're going to be doing today is everything that we have been doing in the past, and then I'm going to add 2 steps onto the end. Okay, so step 1 is we want to make sure it's set equal to 0. So it's written in standard form, and the x squared needs to be positive. So what's this mean? Standard form looks like ax squared plus bx plus c, and it should be set equal to 0. So if there's something else on this side, we want to combine like terms. Step 2, is there a GCF? If so, let's factor it out so we can deal with smaller numbers. So set the GCF equal to 0 in the parentheses. So if so, we're going to factor out the GCF, and then we're going to use the x. And see if it can be factored any further. If there's no GCF, then we can factor using the x method or one of our special cases. Then we're going to set each parenthesis equal to 0 and solve. So let's take a look at our first example. And let me double check something. Yeah. So I'm going to show you how to do the shortcut on one of these, probably B, just so we can review again how to factor. So remember, we label our A equals, B equals, C equals. It's all set equal to 0, so we're good to start. So our A is the number in front of the square term, so 1. Our B is the number in front of the regular variable, so positive 8, and our C is the constant, positive 16. Build my X. At the top of my X, A times C, so 1 times 16 is 16. At the bottom of my X, my B, so 8. I'm looking for 2 numbers. They multiply to 16, they add to 8. So that would be 4 and 4. I'm going to split my middle term with those 4's. So it's A squared plus 4A plus 4A plus 16. I'm just going to have my equal 0 off to the side. We're not going to use it yet. If you want to, you can kind of ignore it for now. So I have 4 terms. Now I can factor by grouping. First 2 together, last 2 together, plus n between them. So what's my GCF of the first one? I can factor out an A. A squared divided by A is A. Positive 4A divided by A is positive 4. 4 and 16, I can divide out of 4. 4A divided by 4 is A, or 1A. 16 divided by 4 is 4. Just throw my equal 0 out there. Now I'm going to factor out my GCF. So I have a matching binomial, A plus 4. Then I have this other that makes me left with A plus 4 equals 0. So I'm going to now, we have done the X method and factored and written our parentheses. Step 4, this is a new step. Set each parenthesis equal to 0 and solve. So I'm going to set A plus 4 equals 0, and then this one, A plus 4 equals 0. And solve. So subtract 4 on each side. A equals negative 4. Subtract 4 on each side. A equals negative 4. So these are our answers. They can, since they're the same number especially, they can be written as A equals negative 4. So these little squiggly brackets mean the set of numbers. And because it's the same number, I only have to write it once. Let's do another. So this time, our first term is 1, so we'll use that shortcut. You could always revert back to this method, or we can use one of our shortcuts. So I still need to do the X, so A equals 1, B equals negative 7, C equals negative 18. 1 times negative 18 is negative 18. At the bottom, B, negative 7. If you use your shortcut, you must be very sure about the factors that you throw in your X, because there isn't really a fail-safe method knowing that these need to match when you use that method. So two numbers that multiply to negative 18 tells me one has to be negative. Because they add to a negative tells me the bigger is negative. So they're 7 apart. So how about negative 9 and positive 2? Okay, it's all set equal to 0. So I have x minus 9, x plus 2, this equals 0. So I have factored. This is everything we did from last couple classes. Now I have it set equal to 0. So I'm going to set each of these binomials equal to 0. X minus 9 equals 0. X plus 2 equals 0. For the first, to get x alone, add 9. So x equals 0 plus 9 is 9. The next, subtract 2. X equals negative 2. 0 minus 2 is negative 2. So I could circle those each separately if I wanted to, or I could say x equals the set of numbers, so squiggly bracket. We usually write these in least to greatest order, so negative 2, 9. Now, what does that answer mean? This answer, we'll get more into this later on in this unit, but this answer is where our shape crosses the x-axis. These are called our solutions, or our roots, or our zeros. So negative 2, that means like about there. Positive 9, that'd be here. Okay, and we have this unit, we're dealing with quadratics, and that ends up being a U-shaped. We call this shape a parabola. So the solutions that we just found, so we solved this quadratic and we found these solutions, and that's actually where the parabola crosses the x-axis. Let's do a couple more. Okay, so this one, I have a squared value and minus another perfect square. So I could absolutely make it 0, y in the middle, and do the x method. Or I could say, okay, square root of y squared gives me y. Square root of 36 gives me 6. So this is y plus 6 and y minus 6 set equal to 0. So y plus 6 equals 0, y minus 6 equals 0. For this one, subtract 6 on both sides. Y equals 0 minus 6 is negative 6. This one, add 6 both sides. Cancel. Y equals 6. Two solutions. Or you could write it as y equals, squiggly bracket, negative 6 comma 6. The other way to write it, this one is different again. Because it's positive and negative 6, I can write plus or minus 6. Because that means positive or negative 6. So we have 3 different ways we could write it. Let's do another. All right, D. 5s squared minus 20s. So this time each of them has s's. Also, they're not perfect squares. 20 is not a perfect square, neither is 5. However, if I look at step 2, it says, is there a GCF? So can I factor something out? Well, let's see. 5 and 20, those are both divisible by 5. So I can take out a GCF. So I'll take out a 5. S squared and S, I can take out an S. 5 divided by 5 is 1. S squared divided by S is S. Negative 20 divided by 5 is negative 4. S divided by S, cancel. So this is equals 0. So now, S minus 4, I can set that equal to 0, and 5s, I can set that equal to 0. So each piece was set equal to 0. Just like here, each piece was set equal to 0. So here, divide by 5 on both sides. So s equals 0 divided by 5 is 0. Here, add 4 to both sides. S equals 4. Two solutions. Or 0 4. Okay, we got 4 more examples. E. So it's set equal to 0, so that tells me I'm good to get started. My first term is not 1, so I cannot use that shortcut. None of these numbers are divisible by like 2, so can't do anything there. I'm going to go ahead and start my X method. So A equals 2, B equals negative 12, don't forget the sign, C equals negative 40. At the top of the X, A times C, so 2 times negative 40 is negative 80. At the bottom of the X, B is negative 11. So let's go ahead and pull up factors of negative 80. Negative 80 divided by X. Remember the X is next to the green button. Second graph. I want them to add to negative 11. So negative 2 and 40, that adds to positive 38. So I'm going to keep going the other direction. 1 and negative 80, that adds to negative 79. So nope. 4 and negative 20, that adds to negative 16. 5 and negative 16, those are the golden numbers. They add to negative 11. And if you're not sure, press second mode. 5 plus negative 16, negative 11. Perfect. So 5 and negative 11, or negative, 16 was the numbers. I'm going to split that middle term. Does not matter which one we write down first. So if I choose to write down the 5 first, I'll have 2x squared, splitting an x term, so plus 5x minus 16x minus 40. I'll tack on the equals 0 at the end. Now we have 4 terms, factor by grouping. What can I divide out here? Well, I cannot divide any whole number, but I can take out an x. X. 2x squared divided by x is 2x. 5x divided by x is positive 5. All right, and the biggest number I can divide 16 and 40 by is 8. I'm not sure if I need positive or negative yet. Negative 16 divided by 8 would be negative 2. I want it to be positive, so I'm going to take out a negative 8. So I get positive 2x. Negative 40 divided by negative 8 is positive 5. Okay, so final factoring step will be to factor out the match, so 2x plus 5. And I'm left with x minus 8. So I have factored completely. Now we need to solve after factoring. So 2x plus 5 equals 0, and x minus 8 equals 0. For this first equation, subtract 5 on both sides. Those cancel. So 2x equals 0 minus 5 is negative 5. Divide by 2. So x equals negative 5 over 2. Or I'm okay if you put negative 2.5. And then on this one, add 8 to both sides. X equals 0 plus 8 is 8. So here's our 2 answers. Or we can write it as negative 5 over 2, comma 8. Okay, let's do F. 3x squared plus 33 plus 84. Let's see if we can take out a GCF, because those numbers are pretty darn big. I know that 3 goes into 33. Not sure if it goes into 84, so let's check. 84 divided by 3. Yeah, 28. So I'm going to take out GCF first. This is going to allow me to deal with smaller numbers. So divide out of 3. So I have x squared plus 11x plus 28. Now I'm going to build my x using a equals, so I'm ignoring this top, a equals 1, b equals 11, c equals 28. 1 times 28 is 28, at the bottom 11. So it'd be 4 and 7. 4 times 7 is 28, 4 plus 7 is 11. Just for practice sake, let's split our middle term. X squared plus 4x plus 7x plus 28. I needed to just kind of leave this 3. I know this 3 out front is going to drop down to my final factoring step. So I'm just going to do that. Cannot just like delete it right now. Grouping. I can divide out an x of this first parenthesis, so I'm left with x plus 4. I can divide a 7 out of this one, positive 7, so x plus 4 again. Now if I divide out my GCF here, so x plus 4, I'm left with x plus 7. And yes, I could have just pulled right from my x. Now, as it says here, okay, if there is a GCF, set the GCF equal to 0 and add the parentheses equal to 0. So can the parentheses be factored further? Yes, that's what we just did. So I'm going to set each of these equal to 0. This one, 3 equals 0. That's not true. So I can now throw that out. This one, x plus 4 equals 0. This one, x plus 7 equals 0. Here, subtract 4. X equals negative 4. Subtract 7. X equals negative 7. Answers or negative 7, negative 4. 2 more. All right, on this these last 2 here, we can't quite start yet because I don't have it set equal to 0. So I need to make sure I put this in standard form. So I need to put it in the ax squared plus bx plus c first. So I need to move the negative 20 to the other side, so I'll add 20 to both sides. On the right side of my equal sign, they cancel, so equals 0. On the left side, none of these are like terms, so it's m squared minus 9m plus 20. So I'm going to label my a, b, and c. A is 1, b is negative 9, c is positive 20. Build the x. At the top of the x, a times c. So 1 times 20 is 20. At the bottom, b, negative 9. Two numbers that multiply 20 add to negative 9. They both should be negative. Negative 4, negative 5. Because my first term is 1, I can go ahead and use my shortcuts. So I can go ahead and say, all right, well, we're using the letter m. So it's m minus 4 and m minus 5. Set each of these equal to 0. M minus 4 equals 0. M minus 5 equals 0. Solve. Add 4. M equals 4. Add 5. M equals 5. These are both my answers. Or I can write squiggly brackets 4, 5. Last one. I want to get this 45 to the left. It's positive, so I move it to the left through subtraction. On the right, they cancel, so it's 4x squared minus 11x minus 45 equals 0. I'm going to build the x. A equals 4, B equals negative 11, don't forget the sign in front of it, C equals negative 45. So we're going to get some bigger numbers this time. So I'm going to type in 4 times negative 45. A times C, negative 180. At the bottom, negative 11. So I'm going to find my factors of negative 180. So y equals negative 180 divided by x. Second graph. I need to add to negative 11, which means the bigger number must be negative. And I need them to be 11 apart. So like all the way down here. 6 and negative 30, that's negative 24. Okay, 9 and negative 20, those are 11 apart. So negative 9, oh sorry, positive. What did I do here? Ooh, positive 11 right there. I accidentally dropped it down as negative, so make sure you put yours as positive. Positive. That means this 9 needs to be the negative 1 and the 20. So let's triple check this. Second quit. Negative 9 times 20 is negative 180. Negative 9 plus 20 is 11. So we're back on the right track. I cannot use my shortcut because my first term is not 1. So I must split the middle term. 4x squared. Does not matter which one I drop down next. I'll just do the 9 first. So minus 9x plus 20x minus 45. I'll throw the equal 0 to the side. Now I'm going to go ahead and do the grouping. First two together and last two together, plus in between them. My GCF of 4 and 9. I cannot divide out any numbers, so I'll just divide out x. So 4x squared divided by x is 4x. Negative 9x divided by x is negative 9. My next thought process is I need to get this parentheses to match this one. So I could be thinking, how do I get from 20 to 4? Well, I divide by 5. 20 divided by positive 5 is positive 4x. If I needed it to flip its sign, I would just divide by a negative, but because I don't need to, it'll be positive 5 here. And always double check. Negative 45 divided by 5, negative 9. Don't assume it'll match. Now that I have these matching, I'm good to start moving on. So I'm going to take out my matching piece, 4x minus 9. And when I take those out, I'm left with the x plus 5 equals 0. I have fully factored. Now I need to solve. So set each of these equal to 0. This one's fast. Let's do that one first. Subtract 5. Cancel x equals negative 5. That's one of my answers. This one's a two-stepper. So we'll add 9. Cancel. 4x equals 0 plus 9 is 9. And divide by 4. X equals, I will accept 9 over 4, or you could divide that in your calculator and get 2.25. Two answers. Write it like that, or the set of numbers, negative 5, 9/4. So really, the only thing that has changed is we're setting it equal to 0. Okay, so these are set equal to 0. Everything is the same until you're done factoring. So you get the parentheses in the questions or your answers like the last couple classes. Then we just tacked on those 2 extra steps at the end, setting each piece equal to 0 and solving for your variable, typically x.